And what we're all about the engines. The focus we have is on making the engines as fast, efficient, as powerful as possible. So it's all about super fast, super scalable, super lightweight. And I say it's written in Java, so there's a really rich Java API, but there's also almost exactly the same amount of capabilities within REST APIs. So even if you're not a Java developer, and we do have people using this from .NET and even other bizarre languages, where they're just accessing us through REST as well. So yeah, even if you're not a Java head, then there's something really useful for you here. So that's it in words. Here's it in pictures, boxes. I know we as developers like to have boxes that we put things in. What you get with the open source libraries is not just some Java libraries, but also some UI and applications around it. At the top level, there's some applications for designing business processes, decision tables, things like that. There's an application, end user application for users' tasks, inbox starting processes, things like interacting with forms. And there's also administrative application as well. So if you actually want to actually see what's going on within the engines, to be able to drill in and see, modify and tweak things as if you were like an administrator. I'd say all of those applications are talking through the REST API. So everything that you see me doing here with the UI, there's a REST API for, so you can put your own surface on top of it or your own sort of orchestration to drive drive the activity into Flowable as you want. Now within that, there's a bunch of engines, and we've shown it all in one big box, the core engines. Now each of these engines can run independently. So if you only want the BPMN engine, you can run it independently, and it sort of looks after its own schema and everything else. If you wanted to add in case management, then it will look after its schema as well. But there are certain things that it shares, things like tasks and jobs. And then when you start putting these engines together, they automatically start sharing these services. So the architecture of this is something which allows you to distribute the engines as widely as possible as you want, but they will share services when appropriate. And also we have a repository for actually keeping the models that you're working in and working with them. And where you sit that on top of, what sort of relational databases, what platforms, there's a whole range of possibilities that you have there. The other thing that all of this, when I say we're focused on the engines, is focused on the engines, but also in a way that allows you to adapt, adjust, and extend it. So there's all sorts of places throughout the layers there where you can take it and make it do what you want. And one of the things that is very much our focus is we try not to be opinionated about the way you should do things. We let you do things the way you want to, and just give you all the different places that you can make it and adjust and adapt it as you like. So that's what Flowable is, and I'll show you it running in a second as well. But why would you choose Flowable over one of the other open source business process engines that are out there? As I said, we're all about the engines. Our focus has always been driving the technology, the concepts in the engine further and further. How do we make it scale faster? How do we make it scale bigger? How do we actually take it away from being a really rigid business process management concept to something which is more appropriate for today's technologies, where things are a bit more dynamic? Stuff doesn't just follow rigid processes. When you talk about business processes these days, they need to be quite dynamic, quite adaptable and everything else. And that's something which we are taking right down to the engine level to make sure that these engines can actually deliver that type of flexibility in today's world. The other thing is, I've been talking very much around it being something that is very developer focused. It is something which business users can use as well. With the applications there, a business user can actually get up and start using and prototyping and playing with things without having to involve a developer at all. I don't mean developers are bad, I just mean sometimes it's quite useful not to involve a developer. Yeah, so having some of this visual design time. Also for you developers, it means there's something already there. So if you want to, impress your friends, here's something, you can just take and plug in a nice rich Visio-style web editor for business process management into your own app, and suddenly you're a superhero. The other reason, as I've been saying, why Flowable is really, we don't like saying this is the right way to do. Well, I mean, when it comes to the engines, yes, this is the right way to do things. But when it comes to how you use the engines, where you want to use them, whatever, there's so many different bits of technology changing, so many things coming out. You know, what type of queuing system you use, fine. You know, there's easy places for you to plug in and extend whichever queue you want to do, whatever application server, everything else. You know, you use the tools that you like to use, and be sure that you can plug up the Flowable engines in where you want. Yeah, and you know, in terms of technology, things like this, the core, when you talk about business and process management, there is a lot of it which is very transactional. So relational databases still are very important to the running of a business process engine. And a lot, pretty much all the BPM engines out there are relational. But there's lots of things you can start doing to start putting things in other non-relational places, or taking things and working more asynchronously. So again, we put lots of hooks in. We try not to be opinionated. If this part of the data model needs to be transactional relational, it can be. If another part of the data model within the engines doesn't have to be, you can plug in your own data layer there as well. So there's all sorts of ways you can take and use this in very innovative ways. So that's all very exciting, nice lot of words and a blank screen, good. Demo, yes. What I'll do now is I'll switch to running a system that's running Flowable. And all this is, what we've got running here is literally, if you go to the flowable.org site, there's a zip you can download, you know, just, I know there's also Maven and all that other stuff, but literally you can download the zip. In there's some WAR files. Dump those WAR files in something like Tomcat, whatever, start it up, and then you've got what I'm going to be showing you next. If I can find, right. So this is the design application written in Angular. Like I say, everything that's happening here is talking to REST, so you can drive this yourselves without this pretty front end. And what you have a number of different tools for editing the different parts, different bits of a business process management engine, case management, or forms, whatever. And literally, you can just go start designing a model. So here I can just say I want to create a new business process management model, BPMN model, and I can just start saying, well, I'm going to have a two-step process, and the first step is going to be called step 1. Second step is going to be called, come on, guess step 2. You know, so I can just literally drag and drop and build a process like this. The flow that I'm going to go through, have all sorts of branches, things like this. I can associate forms with things. So if I want to add a form to a particular task, a particular step, oops, different scroll. Where's the form reference? So I can just go and say I want to create a new form, and literally just start dragging and dropping. So I'm going to have a text field here, and that text field I'm going to call, you know, name, and I've got certain things which, you know, I can put around it. So all of these things are there already for you to get going with creating a little application, a process with forms and things like this. I'm not going to save it. What I'm going to do now is, I'll just save this so we've got something there. I have already prepared a process which I'm going to import, and I'll talk you through that, which has got a few more things in it just to save me trying to paint it and draw it all in one go. So I've imported an app. An app is a container for business process model, a form model, case model, decision table model, everything. It's just a wrapper that puts it all there. So I've got a single model within this application. I could have multiple models, so an application gives me a way of grouping a set of processes together. So if I've got all my human resources processes, I could group them together and say, well, you know, hiring someone, you know, recruiting someone, going through whatever, an annual review process, that I could have all of those associated with one application. What I've got here is just a simple app with a single process, a loan request process. That's here. Got tools here where I can duplicate it, work on it, everything else. I can download this now as a BPMN2 XML, so that's the standard notation, so I could take that and deploy it in a completely different system, or take it and deploy it in another Flowable engine running somewhere else and use this as just a separate design time thing. what I'm going to do is to explain this particular process is go into the editor, and you see with the editor that you get access to all the, if you know BPMN, then this is going to be, you're just going to be so excited by all these fantastic, wonderful things that you can do with it, and so it just goes on. So you can create really complex, sophisticated business processes. These type of business processes that run banks and run, I don't want to say nuclear power stations because it's actually quite scary for me. But yeah, so this particular process here, what I've got is a number of steps, and then a branch, and it goes through and the idea is very simple. Someone's going to apply for a loan, someone's going to review it, we're going to make some decisions about it, and we're either going to accept or reject it. We're going to use this as the basis for enriching it with some artificial intelligence later. But let me take you through this so you can understand how it works. For the start point, I can associate a form with the start point, so I can, need to fill in some data before we get going here. So with this particular one, all I've got is a form with the full name of the person who's applying for the loan. So the first step, I'm just going to be filling in the user's name. The next step, I'm going to capture some more details and things like who is this task assigned to, who's going to have to fill in the form. All of that can be managed by the assignments, and this could be an individual, could be groups and things like this. This particular form has got a lot more information with it, so this is where I'm starting to collect information about them, what size loan they want, and a bit more about their background. So once I've got that information, the next step is, this is a decision table. This is where there's some business rules that are applied to do some initial evaluation around the data I've collected. So if I take a look at that particular decision table, it's done like a spreadsheet. So the idea is that this sort of set of business rules is something you could present to a business user and allow them to understand it or tell you how to how they work, what rules they use for making decisions. And the way you think of it, it's a bit like a spreadsheet, and you can use it like a spreadsheet as well. So you can just sort of insert rows and columns, and it's got all stuff, and you can tab around between. But basically, each row is a rule, and you can read it. Sorry, I'm going too fast. Does it use any particular engine? No, this is an engine. It basically, there is a DMN engine as part of Flowable. So there's the process engine, a forms engine, a DMN decision table engine, and a case management, a CMMN engine. Yeah, so this is a decision table, and we can execute a decision table. Treat each row as a rule, and on the left-hand side, these are the conditions. These columns are process variables or variables that I will have collected within the process, and on the right-hand side, these are the conclusions if the conditions match. So take the first row, for example. It's saying that if the age of the whatever it is I'm talking to about is less than, so you've got all the operators, things like this, less than 25. So if the age of the person is less than 25, it doesn't matter what their status is, I'm going to set the guidance variable to the string young, so need further checks. And so you can create a whole set of business rules, and you can have different ways of interpreting the rules, whether you go through all of them in turn, stop at the first one that matches, collect up all the ones that match, and things like this. So there's all different ways of working. I'm not going to explain decision tables, but yes, it's like a rule engine, but with a particular set of notations. Again, standardized, so you can take this and run this in other DMN compliant engines. So at this step, I've collected some data, I'm going to make a decision, I'm going to sort of generate some guidance text that I'm going to now go and display in the next step. If I go back to the process. So I've generated some advice. At this step, I'm going to present a form again. And you'll see right at the bottom, similar information. I'm just presenting the information for someone to make a decision here. The guidance, that variable is now going to be displayed in this form. And literally, I've just had to make sure I use the right name for this field, and it will go there. So I'll get the guidance. And from that, the other key thing here, which I should have paused a bit longer for, on the form. One of the other things with forms is, as well as having fields that you can collect information on, you can have outcomes. And an outcome is a special thing. And here I've got 3 outcomes. reject, consider, accept. And this is displayed on the form. This allows you to, the user to click a button that says what outcome they want. And then you can use that later in a process to make a decision around which particular way I go or something else. So depending on which button a user presses at this point, then I can now go and branch, and I can either go down where we tell them they've been rejected or tell they've been accepted, or if it was maybe, it can go to another level of review before being accepted or rejected, and ultimately, ending. So yeah, at the final point after that, then the thing is finished. So there we go, that's a simple process. What I've defined, all the tasks, all the user tasks are assigned to the person who started the process, just so I don't have to keep logging in, logging out. So what I can do now, I've defined the process, I've got all sorts of things going on here. I need to deploy this application to make it live. So if I publish this now takes all those definitions and pushes them to the runtime engine, all the DMNs, BPMN and everything else, and all the forms. Now that's published, I can switch to the task application, and if I reload this, we've now got a loan app, and if I click on the loan app, you can see that if I go to the processes tab to start a process, there's one process, the loan request process. If I'd had other processes in that application, they'd be listed here for me to start. And you can see the start form for the full name is here, so now I can put in the full name. So we're going to have Jane Doe. So I've started the process, so it's taken me to a view where I can see the state of the current process. So you can see there's an active task, the capture application details. Remember, that was the next step in there. So as the person who started this, I can always come back here and see the state of the process, see what's going on here, and I'll come back to the minute. But yeah, so there's been a task that's been assigned to someone. So if I go to my task inbox, we can see here's the task, here's the form, ready for me to fill in for the next step. I can also do things where I can actually create completely ad hoc tasks as well if I want to create a remember. If I could type. I can have a completely dynamic set of tasks, ad hoc ones as well. And when I have tasks that come to people, as well as having forms, you can also do things like, if I wanted to get someone else involved in working with this, I can involve someone else so they can collaborate with me on the task. I can attach documents to a task, so if I needed to sort of add additional information, or if I want to just, add a comment here. You can have some social sort of collaboration around tasks as you're building them up as well. So anyway, so back to the process in hand, capture application details. So there's some information I need to fill in here. I'm not going to involve other people. I'm not going to add anything else. I'm just going to say, Jane is asking for 10,000 for the loan. She's rented accommodation. She's 23, and she is going to be Belgian today. And her income is 50,000. So if I press complete now, that task will be finished and it will go on to the next step, which, if you remember, was a decision table. The decision table would look at that data I put in and then generate the guidance text, and then it would go to the next task, which was for the person to review the overall application. And that again has come back to me, so here I am, I'm at the loan review task, and if we look here we can see the information that came in, and we can also see that the decision table, that first rule fired because Jane was less than 25, and we've got this text here. Now, I mean, obviously you could do something far more sophisticated with the decision table. I'm just giving you a very simple example here. You can also see we've got the outcomes here, as well as, instead of just completing a task, I've got really the option of rejecting, considering, or accepting it. So at this stage I could say that I'm going to reject Jane. And then it goes on to taking the path now where it would be to inform the rejection. Now this, I've got nothing here for this task, but it could have been sending out an email, it could have been invoking a web service, or calling a Java service, or something else to actually do additional stuff. Or maybe if I'd accepted it, it would have kicked off some internal processes to go through the whole thing of initializing the systems to be aware that a loan has been sent off. So now, before I quickly switch to that, so before I complete this, remember I said you can always see, as the person who started this, So I've switched to the process view. I started this process so I can see for the current process what's been going on. I can see where it is. So I can always come back here and see, okay, for this particular loan review, what was the information that was put in? So I can always come back and review later on historically as to what's been going on there. There's all sorts of other things here that you can do to play around. So that gives you an idea. You can design quite complex business processes, design complex decision tables, and if you know case management, design case management, and very quickly and easily deploy those, run those, and everything that's happening here. It's happening at a very small scale here on a laptop, but we've got banks that are using this stuff at super mega scale where they're doing hundreds of thousands of transactions and business processes every day, or sometimes even every hour, that the engine can scale from this sort of little world up to that very high and wide scale. So just to give you a flavor, so if I go back to the presentation, now, I've shown you the basics, and I've shown you very simple stuff. Now, as I said, all of this is very pluggable, and also the world of what people want from business process management is changing as well. When you've got a business process, these days you have to deal with things changing. Things need to be sort of far more adaptable. And also, people are looking far more and more where some of those steps, like that, maybe that initial review, did a person need to do that? Could we actually make it so that once a person has sort of put some data in, that when it's done enough times, we could actually learn from that and start automating things? That's what the business is. That's what companies are coming to us and asking us, can you do this with Flowable? So what we've started doing is looking at how we can take some of these sort of very mundane tasks away from a human to allow them to do more valuable, high challenging tasks. So yeah, can we do this in a way also that is not just a magic black box, but is also something that you can come back and inspect and understand, okay, the machine said to go this path. Now, why did the machine say that? How can I take that? Can a human understand those decisions that are being made? So these are the type of things that people are asking us to do, and this is the type of technology that we're starting to look for. And this is where it gets far too complicated for me to deal with, and I hand over to Joram to explain it all. But we have to do a switch.
I'm not going to touch. Thank you. You was waiting for it.
I was, yeah. Disappointed now.
All right, good morning. Can you hear me? All right. Good. So what we're going to do now is, you get the whole demo from Paul. We're going to take the process that Paul has built and we're going to augment it with some machine learning, because if you've seen in the agenda of CODEMOTION, machine learning, there's a gazillion of talks, it's everywhere. So we're going to show you how you can actually use machine learning in a way that you can understand and can actually get better results of the process that we're building. But before that we do that, I'm first going to take a little step back as, why we're doing this. Now, if you go to any business process management vendor out there, you go online, do some research, you will typically find this kind of a circle kind of thingy. What it's about, well, that's what they sell to the business, is why you do BPM. Is you start at the top with designing your process, talking to your people, mapping it in a diagram, as Paul shown you. You're adding some code, you're adding some services, some orchestrations. You're going to run it, you're going to give it the forms to the users, you're going to, some way they're going to interact with it. Important to know is that the Flowable engine is constantly going to monitor, is going to save all the data that has, as Paul said, if you're doing 100,000 a day, it's going to save it into a data store. And the idea is then that you're going to use that data to find bottlenecks, to see, okay, here's where people are waiting on each other, here's contention, here's problems, and you're going to try to fix those bottlenecks. And it's in this last, and of course, that thing constantly improves, and that's the value. That's why you're doing BPM, is because you're constantly evolving together with your company and trying to make a better company, let's say. Now, where can machine learning help? Well, this last step, the optimize step. So we've got all of this data. Remember, 100,000 of processes a day. We've got a lot of data. What we're going to do with this enormous amount of data is we're going to build some prediction models. You'll see later how we do that. With those prediction models, we can do many things, but the two things we're going to do today in code is, the first one is pretty easy, is we're going to use those predictions to make suggestions to the end user, right? So if we can predict the future of the process, maybe we can inject some suggestions to the users how they can quicker fill in their forms or maybe other stuff. At the top, there's a second use case, is we're going to use those prediction models to actually generate on the fly improvement suggestions for your model, right? You saw the model. We're going to use machine learning to actually show to the end user, to the modeling user, hey, maybe you should think about this, and I'll show you how this is done. These are the two use cases. Keep those in mind. That's where this whole demo is all about. Now, why is this a good idea? Why is this a perfect fit? Typically, when you do machine learning, you have a big problem. You've got all kinds of streams of data, and you've got to correlate these, right? You've got to make sense of them. Well, with the Flowable Process Engine, you're actually in a very luxurious position in the sense that you are, let's say, on top in a bird's eye view of the architecture. You're going to call out to services, you're going to orchestrate them, you're going to have forms for users, and basically you already have the structure. You already know how the data flows, right? You saw in the diagram. You can already make a lot of sense from your data, and that's much harder if you're using different tools, different products. You first start cleaning the data, making sense of them. That's not the problem that we have, as you will see quickly in the demo. Now, that's the stuff we're going to build. Now, don't be scared with all the boxes. We'll go through each of them in codes. Basically, well, first of all, the things that you see here, they're all independently scalable. So they're all microservices. Any of these can be scaled independently from the other. Now, for demo purposes, I'm going to use one node only. As you can see, I'm just going to show you what I've got running here. So each of these boxes here, I've got, just before the talk, I've started all of these up. It's not really visible, but it's just to impress you. But basically, the idea is that any of these could be scaled. But if I do that, I've only got 16 gigabytes of RAM in this machine due to Apple's decisions. It's going to melt into the floor and whatever. So let's not do that. We're going to use one service only. But keep in mind that everything's designed for scalability and independently from each other. So what we're going to do is the story starts here on the left-hand side is the process service. We're going to take the process from Paul and we're going to run it a lot of times. So we're going to hit a REST service later on. It's going to start while I'm talking, going to generate data on the fly. We're going to push that data into RabbitMQ. Now, as Paul said, we're not opinionated. I'm now chosen RabbitMQ and Elasticsearch and Spark. The Flowable really doesn't care about that. We give you the hooks and pluggability points to actually do what you need to do, but the actual implementation is up to you. You'll see that later in a minute. It's quite important to us. It's one of our core principles, is that if you would like to switch this with, I don't know, Kafka, ActiveMQ, fine, no problem. If you want to switch this with Mongo, there's no problem. If you want to switch this with TensorFlow or Keras, I don't know, it's possible. Anyway, so we're generating these processes, we're generating data, and we're pumping that into RabbitMQ. We're going to have a little Spring Boot listener here that's just going to take JSON, because the history, we're going to send the history with JSON to this queue. We're going to take it off the queue. We're going to pump it into Elasticsearch. And then we've got what we so-called the decision analysis service. What we're going to do here is we're going to periodically inspect the process, and we're going to see if we got enough data, and then we're going to do some analysis on that. And we're going to kick off a Spark job. That Spark job, we got a small Spark application. What we're going to do there is we're going to use machine learning algorithm, namely the decision tree, and we're going to basically use the data in Elasticsearch. We're going to do that in a very efficient way, so maybe you can't read it here, it's very small, but we're going to stream the data as RDD, and RDD is a short name for a resilient distributed data set, I believe. Basically, it means that Spark, typically you set up Spark as a topology of different nodes, right? And Spark, you're going to give it an application, and Spark will make sure that it's distributed over all of these servers, right? It's pretty cool. And the RDD integration with Elasticsearch works in that way is that if we have a lot of data, you cannot have all of this stuff in memory, right? It's going to be too much. So by using the Elasticsearch RDD integration, we're actually going to stream it whenever we need it. So the algorithm is pretty smart, and it's going to fetch it from Elasticsearch whenever it's needed, and going to just spread it over the whole cluster. So that's basically in a gist what we're going to do. And don't worry, we're going to go into each of these services in detail. One thing to remember, as Paul said, is one of the core things about the Flowable Process Engine is that it's embeddable, meaning that basically you take your favorite build tool, Gradle, Maven, whatever you fancy, and you can just add a jar dependencies to it and go with it. Now, in this whole architecture, everywhere there's an icon here, there's an embeddable Flowable engine. So you'll see it's very easy. I'm using Maven in the demo. You'll see that I'm just adding the dependency, and there we go. Because as you've seen, Paul has driven it purely to the UI, but all the things that he's done through the UI are possible by just adding your own dependency, adding the flowable dependencies, add your own dependencies, and build your own application. And all the code of this you can find online. You just go to this URL, the Flowable GitHub repository. There's a Flowable examples specific project repository, and then you go to the introducing machine learning example. So all the code that I'll show you, you can look it up later and play with it, fork it, whatever you want. So remember, our story started on the left-hand side with the process service. What we're going to do is we're going to take the process from Paul and we're going to run it a lot of times to generate some data, right? We're going to push it into RabbitMQ with a feature called asynchronous history. Asynchronous history is a fairly recent feature in the engine. Basically, it means that normally when you go from all the different steps, you do that in transaction, the database transaction. You go from A to B to C, and that's one transaction. The asynchronous history is what it's going to do is going to keep all of that data in JSON. It's going to generate one big JSON blob. It's going to push it into a database, and it's going to be processed later on in an asynchronous way. Now, this might sound like odd because you think, oh, why would that be better? Well, we've done quite some benchmarks, and we've seen that you can have up to 80% of better performance by having this. And for the end user, that's actually the perceived performance is actually much higher. We're swapping here, resources later on to do something faster now. So it's never a magical win. You can't do that with servers. But basically, what we're doing here is we're putting it into the database and we're processing it later. The user will get a way better, way quicker UI back, and the processing of the history is going to be done later. One thing that we guarantee is that this is transactionally correct, right? We had pluggability points before that we could hook into our eventing system, but that was not transactionally fully correct. So we guarantee from the engine, if you use this asynchronous history feature, that it will work in a transactional way. Anyway, that's the first service. Let's have a look at what the code is all about. Here we go. I'm using Eclipse here. Is that readable in the end? I'm using Eclipse here. I'm using IntelliJ at home too. I'm using NetBeans once in a while when I feel adventurous. But I mean, the only reason I'm using Eclipse for this particular demo is because IntelliJ cannot open different Maven projects in one go, and that's exactly what I needed for this demo. Anyway, so this is a simple, let's say, Spring Boot application, as you can see by the annotation here. What we have added here is simply I'm not going to show it, I'll show some examples later, simply added the dependency to our POM in Maven. What do we need to boot up the Flowable Process Engine? Well, first of all, you obviously need a relational database, as you've seen in the picture. So we're going to boot up a regular Ikari data source. I'm going to define, as usual, a transaction manager from Spring, and this is where we define our process engine. So basically what we're going to do is we're going to inject the data source into the transaction manager. We're going to set some things we have to do for this demo, but the important thing is here, so we're going to enable the asynchronous history. We're going to enable the message queue mode for asynchronous history. And the thing I said before is that we are not opinionated, but we give you all the hook points and pluggability points, is that you see here, we inject a RabbitMQ message-based job manager. And if we take a look at that, you can see it extends one of our classes that ships with the engine. And the only thing you have to do is, this is the Rabbit template from Spring. The only thing you have to do is actually just do the sending. So all of the other code, the processing of the JSON and whatever we need to do about this, that's all done in the engine. The only thing you need to tell us is how you're actually going to send it to your message queue. That's why I said, if you're using Kafka, if you're using ActiveMQ or whatever, fine, no problem. You can just swap this out. So that's that. So the other thing is that, remember, we're going to start a number of process instances here. So this is what's going on here. So there's a bit of code here, but let me just give you the idea. What we're going to do is we're going to deploy it as Paul did in the UI. Well, when he clicked that button, behind the scenes, what's actually happening is this. This is our Java API. That's why I'm saying, it's pretty easy to use it in your own application. This is the repository service. Whenever it's about deployments and that stuff, that's the repository service. We're doing a little query here. So we're going to create seeing if we already have it in the system. So create a query with a certain key and just do a count. If there's nothing in there, we're going to have a zip file that's in my class pod and basically deploy to the system. That's when Paul pushed the publish button that actually happened behind the scenes. When he clicked the complete task, right, that's also done in Java in the backend. What we're doing here is we're creating a similar to the repository service. We're creating a task query. I'm generating some random data here just to know when I will start the generation that some stuff will be generated. But the most important point is that this thing here, when in the UI demo just now was the complete button clicked, what happened behind the scenes is that we're getting the task service, we're just completing a certain task and we're giving it a whole bunch of variables, right? That form is just variables for the engine. That's basically what happens. So just so you have a flavor of how the Flowable Java API looks like. So we're now at our first step. You know, we are I'm going to generate them now while I'm talking. So what I've done is some really low-level hacking here is basically, just have a very simple REST controller in Spring Boot. Going to have like a, listening to the start URL and basically going to do that method I just showed you and do it a number of times that I'm passing here in my browser. So I'm going to do that while I am talking. So basically I'm going to start 1,000 process now. Here we go. As you can see, my fancy UI said I'm triggered 1,000 instances. In this demo, if you run it at home, you can see I also used the Spring Boot admin tool. Basically gives you an idea of all the services that are running. This is the service on the right-hand side, decision analysis. This is the listener application. This is the process application that I just started now. I just like this tool in the sense I just give you like a quick, overview of whatever is going on in your system. While I'm talking here, you can see that the RabbitMQ has been, let me just zoom in for a minute. So the yellow one, that's basically the JSON that we're now pumping into RabbitMQ, and the purple one here, that's actually the listener Spring Boot application that is, pulling the JSON into and pushing it into Elasticsearch. So while I'm now, demoing it's going to make some noise of a small vacuum cleaner, but don't worry about that. There we go. So next up is a listener service, right? It's pretty simple. It's a very simple Spring Boot application that does two things: listening to RabbitMQ, pushing it into Elasticsearch. Not much about it, but the one thing that I want to show about this is the way we're using the Flowable process engine here. So we've got some out-of-the-box Spring Boot integration. Remember, before in the previous service, we were basically defining process engine ourselves, right? We were configuring it ourselves. Now we don't have to do that if we're using the out-of-the-box Spring Boot starters that we have. So you can see here, I'm just depending on the Flowable Spring Boot starter, and that's it. The moment you have this on your class path, it will actually see if you have a data source and a transaction and all that stuff that we needed to do manually before. It will actually see that and actually generate or create for you a process engine. So if we now go to the listen application, you can see it's a very simple Spring Boot application. We're doing some setup here. We're having to do a queue binding, a topic, the way that RabbitMQ basically works. A simple container to listen to have a thread pool that listens to these things and execute it. And the most important thing is that we've got this message listener adapter. That's where we're going to hook in our custom logic. So you can see that this is getting in the receiver here, and the receiver has this, which I called very fancy name, my job message handler. Again, the philosophy that we always follow is that this implements something that we give you out of the box, you plug it into our engine, and then it's up to you, right? We give you the hooks and bolts, and you can go now. So remember, we had to do two things. We had to take the JSON from the RabbitMQ, and we had to push it into Elasticsearch. That's what we're doing. So basically, the engine has given us this entity. It's called a history job entity. This basically is a thin wrapper around the JSON. So what we're going to do here is I'm going to just use Jackson to deserialize it. I'm going to do some checking. Basically, we're now only interested in the variables, right? So we're only going to check for certain forms, and then what we're going to do at the end, very simply, send it to Elasticsearch, right? So just take the JSON, filter it, and push it through. Again, you can do way more advanced stuff here, but you get the idea, right? So the next stop, we're almost there. So we're now generating all of these processes. We're generating lots of data. We're listening to them. We're pumping it into Elasticsearch. Our data is now in Elasticsearch. Next step is now we're going to do some fancy stuff with it. So we're going to have what we call the decision analysis service. We're going to periodically check for process definition changes, and we're gonna use the data in Elasticsearch, again, in a very efficient way through the integration with Elasticsearch and Spark. I'm gonna kick off a job. Now what we're gonna do is, first step is we're gonna look for patterns. We're gonna look for human decision patterns. And a human decision pattern is basically, as Paul's shown in the demo, is you've got a form, you've got a human task, you've got a form, and there is a button there which you have to click, like yes, no, reject, accept. And basically the way you can recognize these is you've got a task, you've got an exclusive gateway, it's called in BPMN, and then you've got something that is based on the form outcome here. So visually, is this. In this particular process, we've got two of these patterns. So our algorithm is going to look for these patterns in our process. And this can be done on a generic level. It doesn't, it's not based on any specific process here, but it's going to be done generically. The next step is once we have these patterns, we're going to trace back, right? So suppose that we take this pattern, we're going to trace back to the very beginning. And while we're tracing back to the very beginning, we're going to actually see all the stuff that we touch. So in this particular case, we're going to touch, there's going to be a form. There's going to be another form, there's going to be a service call to a DMN task. There's going to be another form. There's lots of metadata, and this metadata is we're going to collect that when we're actually, tracking back. The next step is we have all this information now. We build up a little small, cute little metadata kind of about our process, and we're going to kick off this Spark job. Right? So let me just show you how that part looks. Where was it? Here we go. Nope, not this one. Small resolution. This one here. All right, so there's a lot of code here, but let me just get the idea. Remember, I said that the first step is finding these patterns, right? Finding these human task with a form, with an exclusive gateway, with an exclusive gateway afterwards. Sorry. In code, this looks kind of like. I'm just going to make it a bit bigger. Kind of like this. Now, just let's not go into too much detail. The idea is that the Flowable API gives you all of the power to do this. So basically what we're doing here is, in this first line, is we're going to find elements of a certain type, namely the user task, and then we're going to basically do a little bit of filtering. We're going to check whether or not it's followed by an exclusive gateway. If it's followed by an exclusive gateway, we're going to check whether all of the outgoing arrows basically contain a form decision, and then we're going to collect them in one list. That's the first step, and then there's more to it, right? We need to build up this whole metadata model, and this is what's happening here. There's a lot of code here because there's a lot of possibilities, but basically what we're doing here is, as you can see, for example, here, we're backtracking and we're finding a form. We're going to get the form definition from the form repository service. You can see that the Flowable API tries to be quite consistent with these concepts. So remember, we had a repository service for the processes. We also have a form repository service for the forms. So that's what we're doing here. We're actually going to query for them, getting the form model out. This form model will tell us what the potential variable types are, and it's going to use that to kick off this Spark job. And in the end, let me do business scrolling. That's what we then do. We submit. Now Spark works in a very particular way. That is, it's not that you can just call Spark from Java. You actually got to submit. It's a bit of a, sometimes it's not that easy to do, but basically you got to package it nicely and then give it a jar basically with lots of configuration. So that's what we're doing here, is we're building lots of metadata, and then we're actually calling Spark, as a server on our local system. As you can see here, we're using a simple setup with just a local with 4 threads. But we're passing lots of information here that we build up. Now, go look at GitHub if you want to know what it means. But basically, what we're doing is we're gathering metadata, pushing it to Spark, right? Now we're coming into the interesting part. Is we can now, yep, here we go. Now what we'll do is we'll tell Spark, okay, you've got these human decisions, right? You've got these forms and outcomes, and can you now, with using some machine learning, namely the decision tree algorithm here, can you actually predict, if you're, you had our process, if you're here in the process, let's say, can you actually now already predict what's going to happen here? Do you have enough data already to predict there? So that we're going to use all of the data that's still being generated now, and we're going to generate something that looks like this. Now this is a very mathematical representation. basically, it says something like feature 4 in a certain vector, and there's a lot of if-elses, but basically, if we can then interpret that programmatically, this would mean that the nationality, remember that drop-down that Paul used, is in either Dutch or Spanish for some reason. So let me show you how that now works. Here we go. Now this is Spark, and Spark, is quite a big beast. So let me try to give you some context. So remember, Spark works on a topology of clusters, right? So what you do in Spark is you're passing it basically always like functions. You're passing it functional building blocks, and all the data that you pass is immutable, right? So this is why we're doing this kind of lots of lambda magic here. So let me just walk you through it. So what we're doing here is this is the getting the data from Elasticsearch. We're getting the RDD, the resilient distributed data set out of Elasticsearch. Again, this will be done in a very efficient way. This call does not mean that all the data will now be fetched from Elasticsearch. Spark guarantees you, the integration here guarantees you that the data will only be fetched when necessary. So the first thing we're going to do is we're going to divide the data into some little buckets. So we've got lots of data of all the different forms that are being filled in. The first thing is we're going to do is, let's say, a grouping. So we're going to take all the data and say, okay, you belong to this process instance, you belong to this process instance, right? We're going to group all the data for each process instance because we want to do some, thinking about each process instance individually. That's basically our base metric. The next step is there's a bit of filtering going on here. There is a filtering when you don't have all the data. You don't care when you have all the data. I see Paul doing this here. He shouldn't have talked that long then if he wants to go quicker now. So basically, at the end, this is where the real stuff happens. What we're doing here in a gist is basically Spark and the machine learning algorithm works, of course, on mathematics. So you got to give it a vector of values. What we're doing here is we're mapping all of these outcomes form data onto, here at the end, a so-called label point. Basically, it's a vector, as you can see here, a vector of value. So what we're going to do is you got this form, right? We map it to different mathematical values, so just floats, and we give it a certain label. This is what it means. Now, of course, you got to remember that this will be done in a very efficient way over the cluster and with a lot of enormous amount of data. So in the meantime, while I was talking, this data has been generated. You can see here that, I don't know if it's visible. Yep. Oops. Here we go. You can see that that code that I just showed you has been running, on the data that has been generating on the fly, and it's generated something, something very simple, a very simple decision tree. I'm doing some interpretation here, but basically what it says that feature 2 apparently is the nationality. So every time you do this is a surprise when it comes out. Now, I'm kind of using, using the data in a special way that I know what it will happen. Basically it says when you're Spanish, oh good, Spanish or just accept it, we trust you blindly, no problem. If you're not Spanish, and if you're younger than 31 apparently, or you're 31, you're rejected, and otherwise you are considered, right? So this is what's happening. We're now having these kind of rules inferred with a decision machine algorithm, meaning that we can now look at the process, and I got a little slide about that. We now have these, this decision tree. We can now, the decision DMN table that Paul showed, the Excel kind of like thing, we can actually map that now. These rules can easily be mapped into a DMN table. So that's what we're going to do. But first of all, remember that we had 2 use cases. The one was enhancing the UI with suggestions. So that's what we're going to do. So here we're going to take the thing that Paul started. I'm going to kill your process, Paul. I'm sorry. So it's a bit, here we go. We're going to do the same thing that Paul did. However, we now have, use the machine learning to create some rules, some suggestions. So I'm going to fill in requested loan like 50,000, age 32, nationality Spanish because I want to be accepted. Here we go. Completed. Remember, we now went to this step of loan review back when we didn't have the machine learning. Paul had to say reject, consider, accept. We still have to do that, but now you can see that the machine learning actually, we did some bit of Angular extra code here. Based on the machine learning, we can now say that with the data we have, it thinks we should do accept. This is a very simple use case, of course. It's just giving it to the user. You can imagine that you can do way more fancy stuff here than just giving an advice to the user. There's just, if you're creative, you can do a lot of things here. But that's basically the idea. We're enhancing the UI, right? The second use case was enhancing our model, right? So we have these, as we show on the slide, we have these rules that we just used to enhance the UI. We can also use these rules now to automatically generate a better model. Now, in reality, you're going to have to present this to your business user. You're going to say, okay, this is what the machine thinks. This is how you should change it. We're now going to do a bit of a quick hack. I simply made a REST endpoint that says swap user task. So basically if you can read this, I'm saying, this is the task I want to optimize with the machine learning data, swap it. So what's happened now, again, with my fancy UI, it says I'll swap this particular task with the DMN table. So if I now do the same thing, the exact same thing as I've done before, Chando, and I show you the diagram. Remember, this was before a human task. We've now swapped it with an automatic DMN task. And basically, the human can now do, as Paul said, more interesting bits. So we swapped this out. So if I now go and fill this in, here we go. Again, I'm going to use the same data, so you can see I'm not cheating. Before, remember that we had this loan review that somebody had to do. This person can now do fun stuff because now we immediately go to acceptance. We looked at the DMN table that's being generated, the rules, and we've said, yeah, it's fine, swap it in, right? And we swapped it on the process definition side of things. We swapped it with an automatic step. No more loan review, right? Again, in reality, this would be dangerous. There's some, smart things you got to do here. But the last thing I want to show you is that this is just not an automatic step. Basically, what also has been generated is a new model. So I don't know if it's visible, but you can see here that basically it says, when you're Spanish, if you scroll a bit to the right, it's not, it's not optimized yet fully. Oops. But it's basically going to say that you're going to be accepted, right? So this generating both the suggestions and the model on the fly. That's what we're doing. Now, this is just, of course, the beginning of what you can all do with these things. It's just some examples of how you can combine different open source frameworks for this. And I give this demo. The last thing I want to say is, of course, if there are statisticians, that's a difficult word in English, people that do statistics. If you have these in the audience, there's this famous XKCD comic that says, of course, we cannot think that we have found a cause. We have found a cause in the data, right? We've seen that this data leads to this outcome. We should not, think that this is always a good thing, as it says here. Correlation implies causation. It's not necessarily true. However, this comic, if you hover it, it always gives you a way more funnier title. The title here, when you hover it on the internet, it basically says, yes, correlation does not imply causation. However, it does waggle its eyebrows suggestively, and it gestures saying, look over there. It's going to give you some insight, at least, into, this is probably when you might have a deeper look, right? This is what we've been doing. Anyway, that was the end of the slide, so thank you very much.